Hey guys, so here's 2.1 notes day 2, limits numerically. Okay, so because of this whole distance learning thing and we're on a block schedule for right now, we actually lose 1 day a week that we normally would have gotten. So that adds up to quite a bit. So that's why you're getting 2 lessons in a day. And hopefully that won't happen all the time, but most of the time you're going to get 2 lessons in a day. And so, yeah, sorry about that, but we have to be able to fit in everything. We need to prepare you guys for that AP test. So that's where it kind of gets down to the wire. So I got to do my job, and that means we have to kind of try to pack things in as best as we can and just make the most of it, okay? So I am going to skip a couple of these examples just to try to make it quick as quick as possible. So this is limits numerically. We just finished notes on limits graphically. Limits graphically are so easy. I hope you guys felt the same way about that. Limits numerically, I don't like to do it this way with a table. There's a lot of details that you have to pay attention to, and I'm good at paying attention to details normally, but sometimes with these it's hard to see the big picture, so these can be a bit of a struggle, but there is a way to do them, and they're not that bad. Okay, so it says below are a table of values for given types of functions. For each table, the type of function represented by the table is given. Use your knowledge of the numerical behavior of each type of function to find the indicated limits. For limits that do not exist, write D and E. Okay, so we're not doing this second example, so let's cross that out. So looking at this first example, I'll zoom in a little bit. It's an exponential function because that's what it says right here. Okay, and I'm looking at these x values. We have starting at the negative on the left there, down to positive, but up to positive or higher positive numbers. Okay, so these numbers are increasing, the x values are increasing. On the y's, we can see that towards the negative side, we're getting more and more and more negative. Towards the positive side, we're flatlining. And I'll explain what I mean by that in a sec. Okay, so let's answer some of these questions. And it says in letter A, we're finding the limit as x approaches negative infinity of h of x. So as we're approaching negative infinity, as x is approaching negative infinity. So if we're going to the left on this little number table here for the x's, -1, -4, -7. So going towards negative infinity means I'm going more left. So I'm going towards negative infinity. Okay. And so that means I am going to the left forever on the graph. Left forever. Okay. So where am I going? Well, let's look at the y values. As I'm getting more and more negative, I'm getting a much smaller number. It goes from +1 to -13, and then it drops to -125. So if I kept going, it would keep dropping even more drastically. So it just keeps shooting down, okay? So that means I'm going down to a y value that is negative infinity. Well, since I am going to negative infinity, well, what's the limit when you're going towards negative or positive infinity? Well, there is no limit. We can't bound it, so it does not exist. D and E. Letter B, the limit as x approaches -1 of h of x. Well, as we approach -1, well, an x value -1 is right here, so as we approach -1, we're at +1. So that one was easy. It's just 1. It was exactly on our table, so we got an exact limit there. Easy peasy. Letter C, the limit as x approaches positive infinity of h of x. So as x is getting more and more positive, a bigger number on the positive side, so 2, 5, 8, 11, and it just keeps going to positive infinity, okay? What would we predict would be happening next, like after 11? What would be happening next? Well, look at these numbers. goes from 2.75 to 2.969 to 2.996 to 2.999. So it's getting closer and closer and closer to 3. Okay, what does that mean? That just means it's approaching. Remember how it was in the graphs? It's approaching that horizontal asymptote. So this 3 actually is a horizontal, I'm going to abbreviate there, asymptote. And it would be at y equals 3, that horizontal line at y equals 3 on the y-axis. Okay. All right, so we're skipping example 2, so we'll go on to the next page, which is where example 3 is. And this one's actually really exciting because look at that table. It's empty, which means we got to fill it out. And all we have is this function right here. And that means we get to pull out our handy dandy calculators. So hopefully you guys have it already. I told you guys if I had you in Math 3, and I'm sure Mrs. Ardito or Mr. Bonner told you in Enhanced Math 3 last year, if you had them last year, that you're going to need one of these, a graphing calculator. Where's my other one? I have a couple different kinds because I wanted to try them out, and I found mine on eBay at the end of last school year. So I have these two. They're pink because pink's my favorite color. I recommend the TI-84 Plus. These ones are both really nice. This one is obviously going to be more expensive than this one because it looks nicer. This one is in color and this one is not. But they both do the same exact things and their buttons do the same exact things. And that's what's kind of nice about these. So a TI-84 Plus is the best way to go. Okay. As far as brand goes, Texas Instruments is the best. We do have TI-89s, and I think the old TI-83s, they're going to be in the front office. It's first come, first served to all the Calc students. So if you need to borrow one of those, you can. Keep in mind, though, the TI-89 is really hard to maneuver. I cannot figure it out. I got one, too. I can't do anything with it. If anyone wants to buy it off of me, you can have it. We have a love-hate relationship with it. It does not like me because I cannot figure out how to work it. But if you know how to work it, you can buy it off of me. I think I got it on eBay for like 50 bucks, so I would like sell it to you for like the same thing. But yeah, okay. And they're on sale at like Target and stuff right now. Like this one I think is on sale at Target. It comes in different colors for like $120, and that is actually really good for this. I think it's normally like $140, $160, something like that. So anyways, I'm going to be using this one because I like this one better because it has the color screen. Okay, so anyways, I'll show you how to get there in a second. I just had to clear my memory. All right, so it says complete the tables in example 3 and 4 using the result to estimate the limit. We're not doing example 4, so you can cross that one out. So we're just doing example 3. Okay, so we need our graphing calculator for this to fill out this table. Okay, so what we're going to do is we need to write or type in this function into our calculator so that we could evaluate them for each of these points. Okay, so what we need to do to type that in is when we're speaking in calculator language, we have to show that there is a difference between the numerator and the denominator. So we're going to have to group the numerator separate from the denominator when we type it in. And remember, the fraction bar in math means division. So we're going to type that in, okay? So when you do that here in your graphing calculator, what you're going to push is this y equals button that my index finger is on. So, oops, so I'm pushing it, and you see y1, y2, y3, y4 all the way down, okay? I only need one equation because I only have one function there, okay? So I'm going to type in, I'm going to hit parentheses, so watch where my fingers go, parentheses, and then I need x, and the x button is where it says link, and there's a bunch of different variables. There's x, I need -4, and I need to close parentheses, and then I need to divide, and there's my fraction bar, start parentheses again, and I need x squared, so I need to hit that x, and then I need to hit this squared button, and then -3, x -4. Close parentheses, okay? And then what I'll do is I'll hit zoom. I think it was zoom. Was it zoom? I think it was zoom 6. And it graphs it for me. Yeah, zoom 6. So maybe for your calculator, you have to hit the y equals button, and then you type in your function, and then I hit the zoom button, and then I hit the number 6 button, and that's how I did this. So here's my graph. It's a rational function because I can see that there is an imaginary vertical asymptote there and imaginary horizontal asymptote here. Okay. All right, so now I need to plug in each of these values. Okay, so to do that, the next button that I need to hit is the Calc button, or the trace button, but I need the calculation portion. So see how it's in light blue and it's on the board of the calculator, not the actual button? Well, to access those things in light blue, I need to hit the second key. So let's write down, we're gonna hit the second key. So second key. And then after that, I'm gonna hit the trace button so that we can access the calc. And then I have to hit the number 1 button because I want a value. And then see how it says x equals and then there's a blinky thingy? Okay, so from there, I'm gonna type in these x values. The first one I have on my table is 3.9. So I'm gonna hit 3.9 and then enter. And then it gives me the y value, so 0.20408816. I'm gonna round that to 4 decimal places, so 0.2041. And then I'm gonna start typing in again, 3.99. Since I'm already in that function mode, it's gonna let me keep calculating different values. Hit enter and I get 0.2004008. So I'm just gonna put 0.2004. Okay, and then 3.999. And I get 0.2004. So 3 zeros this time. So 0.20004. And now I'm going to hit 4. And nothing showed up. It's blank. What does that mean? So I'm going to put underneath that it was blank. Okay. Well, when something is blank, that means that there are 2 possibilities. It could be a hole, because holes mean that a value is undefined, or it could be a vertical asymptote. Well, if we look at our graph here that shows up, y equals 4, 1, 2, 3, 4, would be right about there. Well, that's not at an asymptote. An asymptote, we have a vertical one right here and a horizontal one right here. So at 4, it's not a horizontal asymptote, because that would be a probably y equals 0, or no, because it's not overlapping on the x-axis. So probably like y equals -1 or something like that. So that means it's got to be a hole, according to our graph. So for holes and for asymptotes, it's undefined there. Okay, now let's try 4.001. And I get 0.19996. I'll just go ahead and write all those. 0.19996. And then 4.01. And I get, I'll just put 0.1996. And then 4.1. And I'll put 0.1961, or actually I'll put 0.19608. I'll round it to that 5th point there. Okay, so what was the question asking us to find? It said to use the result to estimate the limit. So we're estimating the limit. Well, what's the limit? It says the limit as x approaches 4. So as we're approaching that undefined point there. Okay, so remember, when we're looking at a limit, we're looking as we approach from the left at the same time as we're looking as it's approaching from the right. So we're seeing where are they meeting, okay? So we have to look immediately around the left side of that number and the right side of that number. And so I see these two numbers right here, 0.20004 and 0.19996. Well, if I were to round these to the nearest tenth, these would both be 0.2. So these are from the right and from the left, they're approaching the same y value. So I'm going to put approaching the same y value. Okay, so I'm going to approximate it to 0.2. So 0.2 is the limit there. Just to make that stand out as the answer. All right, you've used your graphing calculator already. How cool is that? Okay, you're gonna need one, so please make sure that you get one. Okay, that was example 3. We skipped example 4, so we are on example 5. Sorry about that. My fan is on like full blast, and it's like pushing my papers around. And I have a parakeet on my shoulder right now. You guys want to see? Come here, Maple. My daughter named him Maple because her favorite donut is a maple bar. This is Maple. He's very afraid. He doesn't like to be pet. Yeah, very, very afraid. We'll leave him over there. And he can fly. We clipped his wings, yet he can still fly. So obviously something was done wrong, but it's okay. We'll figure it out. All right, example 5. Given below are tables of values for different functions. Classify each function by type. Sketch a graph of the function, then state as many specific properties, including the equation, if possible, of each function as you possibly can. Okay, so let's just start looking at what we have on this table. Okay, and the things that are popping out at me are the things that say undefined. Like I see this -3 is undefined. Okay, well, what's going around that -3? Undefined, we know two things. That means that this is either a whole or it's an asymptote. Well, which one is it? Well, we can tell which one it is by looking at what's to the left of that number and what's to the right of that number. And I see that on the left, the y value is -1.250, and on the right, it's -1.249. Those are super, super close. So that means that they're going towards the same value. So this must be a whole, okay? So let's take inventory of what we have here. Where did my black pen go? Oh, there it is. Let's make a list. So far, we know that there is a whole at the point where x is -3 and the y value is approximately -1.25 if I round it to the nearest 100th. Okay? It's okay, Maple. I'm not going to hurt you. Okay. So the next thing that is undefined is right here when the x value is 1. So again, this is either a whole or an asymptote. Okay, so let's look at the values on the left and the right. On the left, we have a y value of 2,998. On the right, we have a y value of -3,002. They are nowhere near each other. They're on opposite spectrums here, okay? So as the x's are approaching 1 from the left, these are going up super, super high. And as the x's are approaching 1 from the right, they're dropping to a super, super low number, okay? A super high negative number. So because they're doing that, that tells me I'm dealing with a vertical asymptote where on one side it's being hugged going down to negative infinity on the right, and on the left it is hugging going up to positive infinity. So this is not a hole this time, it is a vertical asymptote. Okay? All right, so since I have a vertical, I have it written twice, so that's okay. Vertical asymptote. I'm going to add that to my list here. It's okay, Maple. So I have a VA, vertical asymptote, at x equals 1. Okay? And let's see, what else do we have on this? So I also see on this table 3 more things. First off, try not to scare the bird. If we look on the ends, these y values are super, super close. So at negative 1,000, the y value is negative 1.997. When x is positive 1,000, the y value is negative 2.003. So on this side, as it's going more and more and more negative on the x's, it's approaching, because it goes from negative 0.250 and then it goes to negative 1.997. And we know when it's super close like that, it's starting to slow down, it's starting to flatline, it's starting to get closer and closer and closer to a certain number. In this case, it is approaching negative 2. Approaching negative 2, if we round up. Over here on the positive side, it's doing the same thing. It's slowing down. It is approaching a negative 2.003. So that tells me when we're approaching a number and it's not going to infinity, that we have a horizontal asymptote and it is at negative 2 because that's what it's approaching on the left and the right. Okay, so here we go. One more thing that we have, actually I do want to, no, do I want to add that to my list? No, I don't need to add that. Oh yeah, I do, sorry. I'm talking to myself. Those of you that had me, you're like, oh yeah, that's normal. All right, so that's a horizontal asymptote at y equals negative 2. Okay, and then there is one more thing on this table of values that is interesting to us, and that is this exact point. It is the only exact point on that table, the only one. So we have a point at 0, 1 that we can use when we graph. Oh, Maple. Oh, you can stay up there. Okay, so I think we're ready to graph. So let's start with the asymptotes. I like to use either a marker or a highlighter for drawing asymptotes. I have these markers right here, so I'm going to use these. I'm going to start with the vertical asymptote at x equals 1. So here's 1 on the x-axis, so it's a vertical line, vertical asymptote, and it's always dashed. Okay. And then we have a horizontal asymptote at y equals negative 2. So y equals, it's going through the y at negative 2. Okay, so that's all done. And I want to save this for drawing the actual picture. Okay, so let's add there what we know, okay? We have that exact point. That would be the easiest place to start there at 0, 1. Okay. And we know that on the left of the vertical asymptote, because here's where the VA was, it's going up to infinity. So it's going to hug that wall going up. Okay. And which means that since it's doing that behavior, that's also going to hug the wall going down and to the left. Okay. On that side, we also have a hole at negative 3, negative 1.25. So about right here, I have a hole. So I actually should have put that in first, but that's okay. There's a hole in there. There's a hole. All right. And then we also have to the right of the vertical asymptote, we know that it's hugging the wall and it's going down to negative infinity. So if we're going down, I have to be able to go down to infinity. So if I go above that green line there, I'm not going to make it to infinity because I'm going to be stopped. So that means that this going down part must be below that asymptote, and which means I got to be hugging the wall over this way to kind of fake the rest of it. Fake it till you make it, okay? And this is a rational function. Rational functions look like this. We learned that in Math 3 last year, and they are symmetrical, like they are reflections across that the diagonal there, okay? And that's what it means to be a rational function. So it's said to classify the type of function it is, and this is a rational function. Okay, then it says the state has many properties. We did that already, including the equation if possible. So we are going to come up with the equation. So I don't need this because we're not doing that other example. Okay, that'll be too much. So I need to come up with the equation. It gets hard to teach like this because, like in class, if you guys couldn't see it on the Elmo and I wasn't paying attention to that, you'd be like, Miss Garcia, I can't see. And now I have like no one to tell me that. So I need to try to multitask and remember to look at my screen and make sure that you guys can see what I'm showing. All right, so it's a rational function. So let's give it a name. We'll call it, it's n of x is its official name, so I'm just going to call it n of x. But f of x is pretty typical, so you could use f of x if you really want. Okay, it's a rational function. Rational means fraction, so we're going to have a fraction. Okay, and let's start with our clues. We had a whole. We had a whole at an x value of -3. Well, we know from last year in Math 3, this was chapter 2, when we have a whole, that means we have a common factor in the numerator and the denominator. And since x equals -3, that means the factor must have been x plus 3. And to be a whole, it has to have a common factor in the denominator as well. Okay, so that comes from knowing the fact that that was from a whole. So to remind yourself of that, maybe draw an arrow and say that's because of the whole. Okay. The next part is from the vertical asymptote. Vertical asymptotes are the restrictions in the denominator that are not a whole. So since x equals 1 is vertical asymptote, that means its factor must have been x minus 1. So maybe draw an arrow to that and remind yourself that is from the vertical asymptote in the denominator. Again, that was something that we learned last year in Math 3. Okay. The next thing is the horizontal asymptote. Okay, it says it's at y equals -2. So to use that to get a -2 and not zero, no asymptote or a zero, an asymptote of y equals 0, that means that the degree of the numerator and the denominator must have been the same to get something different from a 0. Okay, so that means that the degree down here, x times x will be x squared, so second degree. Right now, this is just to the first degree, so that means that there must be another factor up there. Oh, I wanted to change colors. Whoopsie. There must be another factor up here because I'm going to need like an x minus c, or you could even put x plus c. It'll still work no matter what, okay? Because now that'll be the same degree. So now, since I know that the horizontal asymptote is y equals -2, since they're the same degree, that means that the horizontal asymptote is the ratio of the leading coefficient. So the leading coefficient, we can let it be -2 in the numerator over 1 in the denominator. -2 divided by 1 is -2. Hence, a horizontal asymptote of -2. Okay? So that's all key concepts that we learned last year in Math 3. Okay? All right, so we have all that. Now, the only thing that we don't know is this value right here, x minus c. We just put in another variable, so we need to find it. But on our list, sorry, I needed water. There was an exact point. So what we're going to do is we're going to use that exact point, because this exact point gives us an x value and a y value that we can plug in, and then the only variable left will be c, and we can solve for it. And then we'll be able to write our equation. So remember, n of x or f of x, g of x, whatever, it's the same as saying y equals. So the y value is 1 equals -2 times plugging in a 0 for x plus 3 times the quantity plugging in a 0 for x minus c, because I don't know what c is, all over 0 for x plus 3 times 0 for x minus 1. Okay? All right. Let's start simplifying. Well, I have these common factors in the numerator and the denominator that cancel. So I have 1 equals -2 times 0 minus c is just negative c. So -2 times negative c is a positive 2c, all over 0 minus 1 is just -1. So this is really 1 equals -2c, because 2 divided by -1 is -2. Well, I just have to solve for c, so I just have to divide both sides by -2, and I'm going to get that c equals -1/2. That's not the answer, though. That's just c. I need to use that now to write the equation. So I am ready to go. I can write this equation. So n of x equals -2 times the quantity x plus 3 times the quantity x. Now, since c is -1/2, that means it must have been x plus 1/2 as in factored form, all over x plus 3 quantity times the quantity x minus 1. And that is the equation. Now on the AP test, I've been told that you wouldn't be asked to do